Workers can typically only supply labor to the labor market. They can't demand labor. And so in graph 9.4, we showed how a labor supply curve can emerge from the consumer diagram. We also showed in graph 9.5 how a supply curve for capital can emerge from the consumer diagram when consumers choose to save for the future and therefore supply capital to the market. But often consumers are borrowing instead of saving, and when they borrow, they demand capital rather than supply it. We can therefore also derive a capital demand curve for borrowers. Typically, we tend to borrow early in life and save later in life, and so early in life we're demanders of capital, and later in life we become suppliers of capital. To illustrate this, we begin by assuming that you have $11,000 of income in some future period and that you can borrow to the present at an interest rate of 10%. Our endowment bundle therefore occurs on the vertical axis, where we measure future consumption as C2, and we measure current consumption on the horizontal axis as C1. Suppose that the optimal choice for a consumer given these economic circumstances is to choose bundle A, that is, to borrow $5,000 to consume now and leave $5,500 for future consumption. If the interest rate for borrowing rises, we can still consume as much as we did before in the future if we don't borrow. But if we do borrow, we can borrow less because we have to pay more in interest. Thus, the budget constraint rotates inward through the endowment bundle. Suppose that on this new magenta budget constraint, our optimal bundle is bundle C. Notice that we've blurred out the lower parts of the budget constraints because we're not drawing things to scale, and therefore the intercepts wouldn't be quite right if we continued them all the way down to the horizontal axis. To isolate the substitution effect, we take the final magenta budget constraint and shift it up parallel until it's tangent to the original indifference curve at bundle B. Notice that bundle B has more consumption now and more consumption in the future compared to bundle C. Thus both current and future consumption are assumed to be normal goods in this case. The substitution effect from A to B then recognizes that the opportunity cost of consuming now has increased when the interest rate went up. Thus, the substitution effect says consume less now, that is to say borrow less, and consume more in the future. The wealth effect emerges from the fact that an increase in the interest rate makes borrowers worse off and thus decreases their real wealth. Because we've assumed consumption both now and in the future are normal goods, the wealth effect will cause the consumer to consume less now and less in the future. Thus, on the horizontal axis, the wealth effect says consume less and therefore reinforces the substitution effect. On the vertical axis, the wealth effect points in the opposite direction of the substitution effect, and because of the way we've placed bundle C here, it outweighs the substitution effect in terms of future consumption. Now notice that because we've assumed that all our income happens in the future, anything that we consume in the present has to be borrowed. Thus, in this case, present consumption is equal to borrowing. So when we transfer the points from the upper graph to the lower graph, where we measure borrowing on the horizontal axis, we can simply drop the points down to the lower graph. Then we just have to be careful to place them at the right height, that is, at the right interest rate. Bundle A happens at the original low interest rate, which we'll assume here was 10%. Bundle C happens on the steeper magenta budget constraint and therefore at the higher interest rate. We'll assume here that that higher interest rate is 20% as we transfer point C to the lower graph. Bundle B happens on the steep green budget constraint, the compensated budget, which has the same slope as the final magenta budget and therefore happens at the same interest rate. We keep that in mind as we drop bundle B down to the lower graph. Connecting C and A then gives us an estimate of the relationship for this consumer between the consumer's borrowing and the interest rate. As the interest rate rises, the consumer borrows less. This is also the consumer's demand curve for capital, because borrowing is equal to the amount of capital that the consumer needs to demand in the market. In panel A, we assume the relatively small wealth effect on the horizontal axis and the relatively large wealth effect on the vertical axis. We'll now see how things change if we make the wealth effect on the horizontal axis larger and the wealth effect on the vertical axis smaller. We'll still assume that consumption now and in the future is a normal good, and thus the wealth effects will still point in the same direction. Because we've kept the shape of the original indifference curve the same and tangent at the same original bundle A, the substitution effect will be the same as in panel A. Thus the substitution effect once again says consume less now, consume more in the future, as the opportunity cost of consuming now increases when the interest rate increases. But because we've now placed bundle C higher on the magenta budget constraint than we did in panel A, the wealth effect on the horizontal axis is now larger. It again points in the same direction as the substitution effect, as the decrease in wealth causes the consumer to consume less now, because consumption now is a normal good. This also causes the wealth effect on the vertical axis to become smaller than it was in panel A. It still points in the opposite direction from the substitution effect, as the decrease in wealth from the compensated to the final budget still causes the consumer to consume less, because consumption in the future is also a normal good. Now, however, the wealth effect no longer outweighs the substitution effect on the vertical axis. Because current consumption is the same as current borrowing, bundles A and C drop down to the lower graph exactly as they did in panel A when we measure borrowing rather than current consumption on the horizontal axis. Again, bundle A happens at the initial low interest rate, bundle C happens at the higher new interest rate. Bundle B happens on the compensated green budget, which has the same slope as the final magenta budget and therefore the same interest rate. It therefore drops to the same height as bundle C. Bundle B is the same as it was in panel A because the substitution effect is the same as in panel A because we kept the original indifference curve the same as in panel A. The demand curve for capital we get by connecting C and A then again has a downward slope just as it did in panel A, but it's now shallower because the wealth effect reinforced the substitution effect more in panel B than it did in panel A. A quick reminder, we're not using point B because point B is a hypothetical point that simply allows us to differentiate between wealth and substitution effects. When we try to illustrate the actual behavior of a consumer or a saver or a borrower, what matters are bundles A and C. When consumption is always a normal good, the demand curve for capital from borrowers is therefore always downward sloping. An increase in the interest rate will always cause borrowers to borrow less. This is even true if consumption now became a regular inferior good. In that case, the wealth effect on the horizontal axis would point in the opposite direction of the substitution effect, but would not outweigh it, therefore placing bundle C in between B and A. C on the lower graph would therefore still happen to the left of A, thus giving us still a downward slope for the demand curve for capital. The slope would be pretty steep, but it would still be downward sloping. The only way this curve could ever be upward sloping is if consumption now were a given good. In that case, the wealth effect would point in the opposite direction of the substitution effect on the horizontal axis, and it would outweigh the substitution effect, thus placing C to the right of A. With C to the right of A in the lower graph, we would then get an upward slope for the demand curve for capital. This seems extremely unrealistic and probably never happens in the real world. Thus we can safely assume that demand curves for capital from borrowers are downward sloping.